So today is the last session for thermochemistry. Only resonance energy concept has to be taught, and we'll solve numericals because in the light of the numericals, only this thermochemistry subject can be realized. Now let us read the question. The average xenon fluorine bond energy is 34 kilocalories per mole. First ionization energy is 279 kilocalories per mole. Electron affinity is 85 is given. Bond dissociation energy of F2 is 38. Enthalpy for the reaction. So first and foremost thing is XeF4 is dissociated. By supplying heat, it is dissociated this way. Try to understand. So how to dissociate? Try to understand this concept. So first of all, 1, 2, 3, 4. So 4 xenon fluorine bond should be broken. Next. So now you got xenon. This xenon should be converted into xenon plus. Xenon should be converted into xenon plus. D is called ionization energy 1. So that's why it is ionization energy 1 plus. Okay. Next what happens? Bond dissociation energy of fluorine is 38. So fluorine F2 is there. So F2 has to be broken. So F2 has to be broken into 2F. So this is heating, bond dissociation energy. Next, this F should be converted into F minus. F should be converted into F minus. This is called electron affinity. So when you sum up, you'll be getting 292 kilocalories per mole. So this is how you should know basically how to XeF4, how it is converted into Xe plus, F minus, plus F2, and all you should know this basically. So any doubts regarding this, let me know.
No, sir.
Okay, fine. Next. Now, let us see. It is a heat of neutralization question. Heat of neutralization question. Equal volumes of HCl and sulfuric acid. HCl and sulfuric acid, H2SO4. Equal volumes, 1 mole you take. Are neutralized by NaOH. Are neutralized by NaOH. Both will be neutralized by NaOH. So, X kilocalories and Y are liberated. So, delta H is equal to X. Delta H is equal to Y here. Which of the following is liberated means minus, not required, but he has given X and Y. Which of the following is true? You know very well. Okay. You know very well. In neutralized by dilute NaOH is given. But dilute NaOH, how many moles may not be given? You might have taken excess. So, is it right? Y is equal to 2x. Y is equal to 2 times. Y will be 2 times that of X. Do you agree or not? Why? Because H2SO4 is giving how many 2H plus? 2H plus. 2H plus will be neutralized by 2OH minus. 2OH. Then you get 2 moles of water. That means you get 2. I hope you understood. You get 2Y.
Yes, sir.
Are you following? Is it right? 2Y is right?
Yes, sir.
Will get
No. I mean to say 2 times that of X. I mean to say Y is equal to 2 times that of X.
2x.
Yes, sir.
Yes, sir.
So HCl is X. So H2SO4 will be 2 times that of X. If it is 13.7 kilocalories, this will be 2 into 13.7 kilocalories. If it is X, this will be 2X. Clear or not?
Yes, sir.
Yes, sir.
Yeah, that way you have to understand. Now, another question. Now, this question is a very simple question. Now, Here you have water. And here you have HCl plus NaOH. Certain ml is given. And now here you have a thermometer. Here you have a thermometer. Thermometer is there. Something like this. Okay. So naturally HCl plus NaOH enthalpy change delta H is equal to mCv delta T. Okay. So when you mix 100 ml, 50 ml and 50 ml, how much it will become mass?
100.
It will become 100 into Cv delta T. Cv delta T is how much? 3 degrees centigrade. Can you see here 3 degrees centigrade?
Yes.
Because
Yes,
delta
sir.
T is given.
How
So
delta
listen carefully.
C?
See,
So
delta.
how?
Listen
So
carefully.
that's 4.2, sir. I didn't understand the 4.2.
4.2.
Yes.
What is the value? Joules and calories, how to convert?
Okay, that one.
4.1.
1
1 calorie,
4.1.
4.2 joules.
And now, listen carefully. Delta T difference will be degree centigrade is fine. Difference delta T. Clear or not? Clear or not? This will be fine.
Yes, sir.
Am I clear?
Yes,
So
sir.
delta T in degree centigrade is okay. No problem. Difference in temperature can be in degree centigrade. Try to understand this, please. Am I clear?
Yes, sir.
Yes, sir.
Anyhow, now, so this it is coming as 1.26 kilojoule. Am I clear? Now, 5 ml into 5 into 50 into 0.1. It will be 5. Similarly, 50 into 0.1 is equal to 5. This is HCl. This is NaOH.
No.
Clear or not? 5 millimole. Are you following or not? So, what is the question? Enthalpy of neutralization per how much is asked?
Per moles.
Per mole is asked. But here, what is it?
Millimoles. Millimoles, sir.
Millimoles. Clear or not? It is millimole. MV is equal to weight by molecular weight into 1000. What is this called? Millimole only, na?
Millimole, sir.
Millimole. Yeah. So that's the reason why you have taken here 5 into easy. Question is easy only, but you do mistakes. 5 into 10 power minus 3. For 1 mole, you have to find. But this is given in millimole. So 5 into 10 power minus 3 is 1.26. 1 mole, how much? Is it all right, everybody?
Yes,
Yes,
sir.
sir.
Yes, sir.
So when you mix this much, and this is the difference in temperature, the heat liberated is 1.26. This is for 5 millimoles. For 1 mole, how much is asked?
Sir,
Yes, please.
sir, that formula I didn't understand, sir. MCV delta T.
What is the, I mean, have you seen the bomb calorimeter?
Yes, sir.
Bomb calorimeter delta E, what is the formula?
Okay, okay, sir. M
What is the delta E formula? NCV delta
MCV delta T. Sir,
delta
yes,
T.
sir.
By M is there.
Okay, sir.
Clear or not?
Yes, sir.
Yes, sir.
Now, it's a nice question. Now, standard heat of combustion of boron, solid boron. So these are solid boron. So always, whenever metal, when you do combustion, you will be getting metal oxide. Carbon CO2 will get. Hydrogen H2O will get. Al, Al2O3 will get. Na, Na2O will get. Mg, MgO will get. Agreed or not? So you will be getting B2O3. Are you clear or not? This is the combustion reaction. You get B2O3. Next.
Yes, sir.
So here, this is combustion reaction. It is also heat of reaction also. It is also heat of reaction. Both are same. So what you write? Heat of formation of products, half into this one, minus heat of formation of reactants. These reactants. Now, you know, elemental state, it is 0. So these two are 0. These two are 0. So this is 0. This is also 0 because it is
Yes, sir.
oxygen. This is
Yes,
boron.
sir.
Both are elements. Elements and molecule. Okay. Now what is the relation? Combustion is equal to half of heat of formation of B2O3. That is the answer.
Yes, sir.
Any problem?
No, sir.
Yes, sir.
No, sir.
That's fine. It's a very interesting question and students do mistake. So please stay focused. The average energy to break PP bond in V4 into gaseous atoms is 53.2 kilocalories per. So what does it mean? Where you do mistake? Have a look. First of all, P4 structure you should know. P, 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 P. So students will be thinking P4 means only 4 bonds. That is a mistake they do. How many bonds are there here? May I know?
Six bonds, sir.
6,
No,
sir.
6 bonds, sir. No, six.
So are you clear now why it is into 6?
Yes.
Here 4P only is coming. How many P is coming here?
4 only,
Four.
sir.
4,
Four,
but
sir.
how many PP bonds are broken here?
6,
6,
sir.
sir.
3 bonds,
Sir.
sir.
I hope you understood this.
Yes, sir.
Yes, sir.
Here only you do mistake. Rest is fine only. Rest is fine, absolutely. So H2. Similarly, H2 dissociation energy is 104.2 is given. That's what it is written here. So first the data is written here. Any doubt so far? Clear? Whatever data is
Yes.
given.
Yes,
Now
sir.
listen
Yes,
carefully.
sir.
Now here what is given? Heat of formation of pH3 is given. So heat of formation means what? How many moles is formed compound? 1 mole.
1, sir.
So 1 mole only,
One.
sir.
By definition, heat of formation is for 1 mole of the compound should be formed. So 1 mole of pH3 is formed. Any problem?
No, sir.
No, sir.
1/4 P4, that will become P. Plus, what is this phosphorus? White phosphorus. That is in the stable state.
Red
Plus
cross.
3/2 H2, you get pH3. Agreed or not? So this is
Yes,
given
sir.
how much? 5.5 kilocalories per mole. Check out. Are you clear or not?
Yes, sir.
Yes, sir.
Now, may I know bond energy definition? Bond energy of products or reactants here?
So
Products, sir.
reactants minus products,
No.
I think.
Combustion and bond energy, reactants minus products. I told you or not?
Yes,
That
sir.
Yes,
both
sir.
Heat of formation will be products minus reactants.
Products minus reactants.
So here also you may do
but I
mistake.
said reactions minus
So
products.
now
only.
see 1/4, see here 1/4 to convert P4 to P, how much? 53.2 into 6. Don't write 4. Are you clear or not?
Yes, sir.
Yes, sir.
Plus 3/2 into H2. H2 is how much? 104.2. Is it all right?
Yes, sir.
Yes.
Yes, sir.
Minus here pH3 means what? How many bonds are formed?
4, sir.
4, sir.
It's
4
3 pH bonds.
bond.
Na? 3 pH
3,
bonds.
yes,
Where
sir,
4?
3.
Yes, sir. 3 only, sir.
What is the structure of pH3? This is the structure of pH3. So 3 pH bonds are formed. So here, how many bonds are formed?
3,
3,
sir.
sir.
3,
3
sir.
pH. So what is the question? pH bond energy.
pH bond energy, sir.
This is the only unknown.
Yes, sir.
You get the answer. Are you clear or not?
Yes, sir.
See, delta H formation from P4 is given 5.5. So delta H is given how much? 5.5.
5.5.
5.5. So this delta H is equal to bond energy of reactants minus bond energy of
Product.
products. So here 6 should be taken care. This formula should be taken care. You'll get the answer. Let me know if you have any doubt. Raise your hand. If you have doubt, I'll explain again.
No, sir.
Fine. Okay. Now, let us see this question. There are two questions here. Calculate the enthalpy of combustion of methane. So, this is the reaction. Now, bond energies are given. So, let us see how to work out. Now, these are the bond energy of the reactants and bond energy of the products. So, what is delta H formula? Bond energy of the reactants
Minus bond energy of
minus
products.
bond energy of the products. So, first independently you find out because many are there, na? That's why. See, first CH4. How many CH bonds are there?
4, sir.
4, sir.
4.
You have
CH
to
bond.
break. You have to break 4
CH4 bonds.
Okay. Plus, how many O bonds you have to break?
2, sir.
2, sir.
So 2 into bond energy of 2 into bond energy of OO. Clear or not? Now
Yes,
Yes,
sir.
sir. Yes,
sir.
sir.
just write the values. You will be getting
Yes, sir.
446 kilojoules. Now may
Yes,
know.
sir.
Just I would like to ask you. This reaction will come negative or positive? These soups, combustion reactions are what? Negative or positive?
Sir, combustion reactions are negative, sir.
Exothermic. Exothermic. You see here 2446 is coming. Reactants. Products, how much is coming? More.
Yes, sir.
Then it will be negative only. See here minus 892. Clear or not? Anyhow,
Yes.
let us see the products. Let us see the products. Now, products, what else is there? CO2, how many C double bond O bond should be formed?
2, sir.
2, sir.
So
Sir.
2. So 2 into this one. Next.
740.
How many OH bonds should be formed?
Sir,
2.
here 2, sir. Sir,
Because
into 2, no, sir. 2
2 water
moles.
is there, na? That's why 2
Yes, sir.
into
2
2 into.
moles. 2. Yes, sir.
Okay.
4.
Yeah. So
Okay.
you get this. So naturally, reactants minus products. So you'll be getting exothermic. This is the answer. Any doubt? Let me know.
No, sir.
Is it all fine?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now listen carefully. Always remember resonance energy is equal to delta H observed minus delta H calculated. So
Calculated.
now listen very carefully. This delta H observed sometimes written as delta H experimental. What is it? Experimental minus delta H calculated. Is it okay? This formula is must. Resonance energy definition. Now let us solve this question. Now calculate the resonance energy from the following data. N2O. So N2O is this one, laughing gas. If you inhale this, you'll be laughing. So N2O. So I've seen a group in Vizag city. Early morning, when I go for a walk, all the group they put one, they'll be rounding and all, and they'll be laughing. And
Yes,
all.
sir. Laughing club. Sir.
Yes, sir.
There is a one type of okay. We should not offend them, but it looks very funny. I hope some of you are there in that. Yeah. N2. What is the heat of formation of N2 or soups? N2 is stable na, N2 plus half O2. How do you get
Yes,
N2O?
sir.
N2 plus
N2 plus half O2 gives N2O.
N2O. So the same thing only it is given here. Any problem? First step?
No, sir.
Fine. Now you know very well. Heat of formation of N2O is equal to what is the heat of reaction?
So products minus reactants.
Product minus
Excellent. Very good. Products minus reactants. Now products are what? These
Sir,
bond energies are given, na?
yes,
Bond
sir.
energies are given. So bond energies are given means reactants minus products. Clear, na? Heat of formations are
sir.
not given. Bond energies are given. Understood
Yes,
or not?
sir. Yes,
So
sir.
reactants minus product. So these are the reactants. These are the reactants. And these are the products. So first this bond should be broken. So NN bond plus this bond should be broken, half O2, minus this bond should be formed. NN bond should be formed and NO bond should be formed. N double bond O should be formed. So N double bond N one bond and N double bond O another bond should be formed. Any doubt?
No, sir.
No,
No, sir.
substitute the values, you get 170. Okay. Now my question
Yes,
is,
sir.
listen very carefully. My question is, this 170 is experimental value or calculated value?
Sir, calculated value, sir.
Huh?
Calculated value.
Calculated value, sir.
Calculated value. Then what is the observed value?
Sir, 82, sir.
What is the observed value here?
82, sir.
They did the experiment. After doing the experiment, they got 82.
Yes, sir.
Okay. So 82 minus
Minus,
170.
that is minus 80.
I hope you understood.
Yes,
This is
sir.
the resonance energy. Observed minus calculated heat of formation.
Yes, sir. Sir,
Let me know if you have any doubt. Yeah, please.
sir, that means for both combustion and formation, bond energy is given means reactants minus products only, no, sir?
Whenever, yes, I'll tell you. See, whenever bond energies are given, heat of reaction will be heat of formation. I mean to say, heat of reaction you can take. So bond energy of reactants minus bond energy of products. Similarly, heat of combustion is also delta H C of reactants minus delta H C of products. Are you clear?
Yes, sir.
So this is about this question. Now let us see diborane. You know very well, diborane is a rocket fuel. It's already explained in third group. So B2H6 plus O2 gives rise to its oxide and water. It's oxide and water, always. You know very well, any carbon hydrate, CH4, if you heat, you get CO2 water. C2H6 when you heat CO2 water. Similarly, B2O3 and water, it's oxide and water we get. It's a very simple thing. Now, it's a very nice question. From the following data, calculate the enthalpy change of the combustion of diborane. So this is the combustion reaction. Combustion of diborane. Calculate the enthalpy change for the combustion of diborane. That means I have to get this reaction. So what is given? Listen carefully. What is this? Can you tell me?
Sir, combustion of borane, sir.
Is soup. Heat of formation of B2O3. Right or wrong?
Yes, sir.
Whatever he said is also right. It is also equal to heat of combustion of boron. Both are right. Agreed, na?
Yes, sir.
Yes,
Very
sir.
good. Very good. So this is heat of formation of H2O. He has given. Okay. And what is this? Enthalpy of vaporization.
Yes, sir.
Water. You should know all these things nicely. Next. What is this? Enthalpy of formation of
Enthalpy of formation of diborane, sir.
diborane.
Diborane.
So these, first of all, he has given enthalpy of formation of different compounds and he asked the enthalpy of combustion. Okay. Now, simple thing. Let us see our technique. B2H6 is which side?
Sir,
Which
right
side?
side, sir.
Right side.
Here left side. Here which
Yes,
side it is
sir.
there? Right side.
Sir, right
Right
side,
side.
sir. So
What you have
minus.
to do? Minus.
Minus, sir.
I'm writing here. Okay, this side I'm writing. Minus. Okay, na?
Yes,
Next.
sir.
Next. What about B2O3? Oxygen, don't worry. Forget about it. Because oxygen in many compounds.
Yes, sir.
So B2O3, which side?
B2O3
Right
right
side,
side, sir.
Right
Here
side,
also
which
right
side?
side, so
Plus,
plus, sir.
sir.
Plus,
Plus, sir.
This plus. 1 mole only, na? 1 mole.
Yes, sir.
Here also 1 mole. No problem. No issue. Now, water which side?
Sir, right side, sir.
right side, sir.
Water right side. This is also right side only. But how many moles are
So
there?
3 into 3
3
into
into
right side.
yes, sir.
This is 3 into. Am I right?
Yes, sir.
Yes, sir.
Yeah. Now listen, there is one more problem is there. I'll tell you. Just listen. Now, equation 1. Okay. Equation 1. What you did?
Plus,
Equation.
sir.
So last equation, what you did? Minus only.
Minus.
Yes, sir. Minus only, sir.
Are you following or not?
Yes, sir.
Yes, sir.
Now listen carefully. Listen carefully.
Sir,
Here, heat, water is what you are getting water.
Liquid form,
liquid,
sir.
sir.
But this should be
Liquid
further
form,
converted into
sir.
vaporization.
Yes, sir. Vapor phase.
That's why you have to add that.
Yes, sir. Heat of vaporization also
You
should
have
be
to add
added.
that. Are you clear or not?
Yes, sir.
Sir, so we have to consider both, sir.
See, try to understand logically. First thing is, here this side, you are getting liquid actually. When you add,
Yes, sir.
then this should be converted into gas. Here the gas is there.
Yes, sir.
Are you clear or not? That's why you have to convert into gas. Is it all right?
Yes,
Yes,
sir.
If you don't take care of that, you should know why he has given this. Because in the combustion reaction
Yes,
at the
sir.
end, you are getting gas.
Yes, sir. H2O vapors we are getting.
If you cool, you'll get liquid, but you are not cooling here. This reaction.
Yes, sir.
But
Yes,
the
sir.
examiner has given that way. What can we do? Is it all right?
Yes,
Yes,
sir.
sir.
So next question. Now, listen carefully. Enthalpy of neutralization of HCl by NaOH is minus 57.32 kilojoules per mole, or minus 13.7 kilocalories per mole. Now, and by NH4OH will be less only naturally. Why it is less? Where it is gone?
The weak base, sir.
Delta H ionization, na?
Yes, sir.
Delta H ionization, it is gone. Remaining is gone. So how much is gone? Can you tell me? Minus 57.32.
57.32,
7.32.
sir.
So I should get minus 51.34. How much will be plus?
Sir, 5.98.
5.98. Huh?
Yes, sir.
Yes, sir.
You've got the here answer here. Huh? And telling. Clear or not? So no need to do all these things. Very simple, right? See. Am I clear?
Yes, sir.
So this is how we should solve the questions. Next. It's a nice question. So there are two gases. Ethane and they use for welding like this. For example, there is a iron rod here like this, something large, okay? And you have to weld, okay? You have to weld this. And to weld this, now what is suggested? Which gas you'll use? Okay, where it is C2H6 or C2H2, ethane. Ethane is called, this is called acetylene torch. You know very
Yes,
well.
sir. Yes, sir. Acetylene torch.
Acetylene torch. This is used for welding, you know very well. But by
Yes, sir.
strategically, you should know. Strategically. See, listen carefully. Calorific value, what I said for you.
So heat of combustion by molecular weight, sir.
Like per gram, I told you not to find the.
Yes, sir. Per gram, sir.
Per gram is the calorific value.
Yes, sir.
So per gram, if you say, how do you get by gram? You have to divide it by molecular weight.
Yes, sir.
Yes,
So
sir.
this is per mole, na given.
Yes,
This
sir.
per
Per
mole is
mole.
given. This is
Yes,
per
sir.
mole.
Per mole, sir.
But calorific value is per gram. So divided
Yes,
by
sir.
molecular weight always.
Molecular weight. Yes, sir.
So that means per gram, how much heat is liberated?
Minus
11.3.
11.37.
Here, how much is liberated?
11.92, sir.
So which is a better gas welder?
Ethane, sir.
C2H2.
Acetylene.
Acetylene,
Acetylene is a
sir.
welding. It is used for welding.
Yes, sir.
So this is how you should answer. So which is a better fuel? Which is having high calorific value? Which is a better gas welder? This type of questions and all you have to answer this way. What is the
Yes.
answer? Always calories,
Greater
kilocalories
the calorific value, greater is its
per
usage.
gram you have to take.
Yes,
So
sir.
that's why whatever is given divided by molecular weight you take. Are you following?
Yes, sir.
Get
Sir,
Yes, sir.
Yes, please.
sir, here they give 1 gram of fuel, sir. If they give any value for those grams, how we have to solve it, sir?
No, by definition it is for 1 gram of fuel. calorific
Okay,
value.
sir.
Calorific value by definition earlier also we did yesterday. It is for 1 gram.
Yes, sir.
Okay, per gram only you have to see. Is it all right?
Yes, sir.
By definition, it is for gram only, calorific value. See, listen carefully. He has not given, try to understand, which possess a high calorific value. So teacher like me has written this, that is heat produced by 1 gram of fuel. What is the meaning of calorific value?
Sir, heat of combustion by molecular weight, sir.
Heat produced by 1 gram of fuel.
Yes, sir.
But this part will not be given in the exam.
Yes, sir. Sir, that one also written in solution only, sir.
Now try to understand. This is not in the question. Try to understand. This will
Yes,
not be
sir.
given.
I didn't notice it.
This is not a question. I have given the hint for you. Heat produced by 1 gram of fuel is called calorific value. Is it okay?
Yes,
Yes,
sir.
sir.
Yes, sir.
Now let us see another question. Now, heat of see, listen carefully. Heat of combustion of certain compounds are given. C2H2. Now it is hindering. 1 second. C2H4, C2H6, H2 is given. Calculate the heat of hydrogenation of ethylene. Very nice question. Now let us see how to answer this question. Yeah. So this is ethylene.
Yes,
When you
sir.
add H2, you get ethane, hydrogenation. This is called
Yes, sir.
hydrogenation.
Yes, sir.
Now, what is given? Let us see here. First, combustion of ethane. So value is given 1409 is given. This is first one, right? So expand it first of all whenever data is given. Next, combustion data of ethane is given. So expand it. Combustion
Yes, sir.
data of H2 is given. You get water. So write the data. So
Yes, sir.
nothing you did it so far. Data you have written. And what is asked you have written here. So far up to here. Any problem? Check out please.
No, sir. No, sir.
No, sir.
Fine. Now let us see here. How to get this? Very simple. C2H4 is which side?
The left side, sir.
Left side, sir.
Here which side is
Both
there?
on left
Left
side only.
side, sir. So plus, sir.
Left side.
So this will be plus.
Yes, sir.
Now H2 is which side?
Left side only, sir.
Left side,
Down,
sir.
sir.
This is also plus. 1
Yes,
mole
sir.
only.
Plus, sir.
Both are 1 mole. Moles
Yes,
also
sir.
you see. C2H6 is which side?
Sir, right side, sir.
Right
Here,
side,
left
sir.
side, sir.
Here, left
Minus.
Yes,
Minus.
man.
Yes, sir.
So check out here. We get the answer.
Yes, sir. Yes, sir.
Very simple actually. Thermochemistry. Naturally, this will be cancelled.
Yes, sir. Yes, sir.
This will be cancelled. Don't worry. Okay. Yeah.
Yes, sir.
Any doubt regarding this question, please? Yeah. Again, another interesting question. Huh? Let us see. Calculate the heat of formation of benzene. Calculate the heat of formation of benzene from the following data, assuming no resonance. So bond energies are given. Okay. Listen carefully. Here, you have to find out the heat of formation of benzene. So how benzene will be formed? Graphite. This is graphite. G is not gas. Solid C6H6 na, plus 3 moles of H2 gas gives rise to 1 mole of C6H6. This is a. Are you clear or not?
Yes, sir.
Yeah. Now, listen very carefully. How to solve this question. Now, so this is the requirement. Okay. This is the requirement. First and foremost thing. Listen very carefully. So, how many? Listen carefully. How many CC bonds should be there? How many CH bonds are required? How many C double bonds or C bonds are required? How many C single bonds are required? Let me know first for benzene.
Sir,
Sir, CH, there are
CH is
6
six,
bonds,
sir.
sir.
CC
3,
bond,
sir.
CH is
C
six,
single
sir.
bond, C3, sir.
Single bond.
So this
Three
is
single
6.
bond is 3,
This
sir.
is 6.
6,
Can you
3,
see?
3, sir.
3,
This
3
is
and
3.
3 and 3, sir.
This is 3. All of you are convinced or not?
Yes, sir.
Convinced or not? So
Yes, sir.
6, 3, 3.
Yes, sir.
Yes, sir.
So this is products. This is for products I am writing first. Any problem?
No, sir.
No, sir.
This is
No, sir.
products. Now let us see the reactants. Reactants means this one. So reactants, first you have to atomize. Listen carefully. This is a graphite. I don't know, you know the graphite structure or not. Graphite is a layered structure, you know or not?
Yes,
Sir.
sir.
It is
Yes,
not
sir.
benzene. Hello, it is not benzene. Mind you, please.
Yes, sir.
It is not benzene. It is like this layered structure. So this should be converted into individual carbon atoms. What
Yes,
is this
sir.
called? What is this called? Heat of atomization.
Heat of atomization, sir.
That's what it did. You did it. 6. Heat of atomization. Clear or not?
Yes, sir.
Next, hydrogens are there. You have to convert it into
Hydrogen atoms, sir.
hydrogen
Atoms.
atoms. So this is actually H2, na? So 3 moles are there.
Yes, sir.
Yes, sir.
So that's why 6. 3 to 6.
Yes, sir.
So I hope you understood. Any doubt regarding this?
No, sir.
Now this is reactants. In the reactants, mostly used heat of atomization. Clear?
Yes, sir.
And here,
Products, sir.
this is the products.
Bond energies are used.
Now, what do you do?
Sir, reactants minus products.
Excellent. Reactants minus products. Cool. Any doubts regarding this?
No, sir.
No, sir.
So if you have doubt, ask me. I'll explain again. If anybody is having doubt, let me know, please.
Sir, here heat of formation means reactants minus products, no, sir?
Sir, here that in
No, actually, the thing is, it is a bond energies. These are bond energies only. Formation of CH bonds. These are bond energies. So formation is what? Minus. Bonds are formed. There is bond energies only.
Yes, sir.
The actually here verbally it is given heat of formation. It is also right, na? Heat of formation is nothing but bond energy only, na? Bond energy of CH.
Yes, sir.
Clear or not?
Yes, sir.
Generally, listen carefully. Generally, heat of formation is for compounds. Clear or not?
Yes, sir.
Yes, sir.
But this is, so this is bond energies actually.
Yes,
Clear or
sir.
not? They are bond energies. You can use, no problem, notation. Now let us see another question. What is this question? NH4NO3. In the second year, nitrogen gas preparations, you will be studying this. Listen carefully. NH4, N, O2 if you take for example. Listen very nicely. N2 is lost. Here you get N2 plus 2H2O. Is it all right?
Yes, sir.
Now
Yes, sir.
NH4, NO3. NO3 means N2 plus 2H2O only, but extra oxygen is there, that's why you get N2O.
Yes, sir. O, sir. And 2.
Clear or not?
Yes, sir.
Yes, sir.
Should know how to write this. N2O plus 2H2O. So he has asked when for this decomposition reaction, how much is the delta H value? So and you find a delta E also.
Yes, sir.
So delta E value to find, you should know delta H. And delta H, how do you find? How do you
Production.
find?
So delta
What is given here? What is given here? Heat of formation is given. Of what? Heat of formation of N2O,
N2O, sir.
comma, water.
H2O, sir.
They're all given, na?
Yes, sir.
Heat of
Yes,
formation
sir.
of NH4 and NO3, everything is given. So, you want to expand and do it? You want to expand?
Yes, sir.
First, what is given? The molar heat of formation of NH4 and NO3 is given. Clear or not? So, write this. How do you write? N2, help me,
Plus half O2.
plus
N2 plus half O2
Half
gives
O2.
NO2, sir.
half O2 gives rise to N2O.
N2O.
Similarly, H2 plus
H2 plus half
O2
O2 gives
rise to
H2O.
H2O.
H2O. So
Yes,
try to
sir.
understand. So this way you expand. Are you clear or not?
Yes, sir.
And heat of formation is how to write products minus
Reactants.
Reactant.
reactants. So you get the delta H value. Once you get the delta H value,
Yes, sir.
then you know how to find the delta E.
Yes, sir. Delta H equal delta E plus NR.
Number of moles is how much here?
Yes,
Number
sir.
of
one
moles.
only, sir.
Here
Because
one,
liquids
only
and
one. This
solids
is
are
a
not
solid.
considered, sir.
This is a solid. This is a liquid. It is one only.
Yes,
Very
sir.
good. Very
Yes,
good. It
sir.
is one. You get the answer.
Delta N is 1, sir.
Any doubts?
No, sir.
Good. So almost we come to an end. Thermochemistry. Last question. Okay. Let us work out this. See here. See here. What is given here? Heat of formation of this compound is given. See how to write the heat of formation of this compound. How to write the heat of formation of this compound? Is it right? Check out here. Clear?
Yes, sir.
Heat of formation of the next compound is given. Is it right?
Yes, sir.
Yeah.
Yes, sir.
Now what you have to find? You have to find this reaction.
Yes, sir.
Then you manipulate these two. You know how to manipulate, na?
Yes, sir. Yes, sir.
So you get the answer accordingly. Now, so this ends, but here one small problem is there. Gas to solid. Gas to solid here. Solid to gas. 222. This should be taken care. So solve these questions. Okay, it will be helping you very much. So in making you strong in this stuff. So I can give a lot of questions and the resonance energy of this benzene and all these things. You can also work out this question. This is a previous examination question. Experimental minus calculated. Yeah. This is the formation of benzene. This is the formation of benzene. Yeah. And you should know how to calculate. Already explained to you this one. This is already explained to you. Is it all right?
Yes, sir.
Yes, sir.
So this ends thermochemistry, and we completed the first year course. So revision session will start from Monday. Okay. So let me know any doubts are there.
Sir.
So which topic
Yeah.
are you going to start on Monday,
Sorry.
sir?
Now,
Oi.
listen carefully. Regarding chemistry, I am going to start alkenes. I'll tell you one thing. Alkenes is the heart of organic of first year. If you don't know alkenes chapter, if you're not perfected, organic chemistry will be devastated. I'm using a word. You never. So alkenes is so important. Please don't miss single class also. It's extremely interesting, very fascinating class. So don't miss classes. When I teach organic chemistry, don't miss classes.
Yes, sir.
So organic chemistry, I'm going to take alkenes tomorrow. I mean Monday. And sir will be taking chemical equilibrium. I hope you are clear for next week. So next
Yes.
week,
Yes.
these two chapters you have for the syllabus on February 6th.
Yes, sir.
Yeah.
Sir,
Yes, please.
sir, here in bond energy of formation of bond plus bond energy of dissociation of bond, there, no, sir. Here in
Yeah.
bond energy of dissociation of bonds, here 6 into H, no, sir.
Listen carefully. Actually, here minus is given, products. This is reactants. So reactants minus products.
Yes, sir.
Clear or not?
Yes, sir.
Yeah.
Sir, here, but in bond dissociation of bonds, 6 into carbon plus 6 into hydrogen, no, sir. In dissociation of bonds, sir. Bond energy of
This
dissociation.
is dissociation. Nah?
Yes, sir.
This is
There-
dissociation. First, you
Yes,
have to
sir.
convert to solid to gaseous state na, to form benzene.
Yes, sir. Yes, sir. Then plus 6 into hydrogen, no, sir. Here 3H2, no, sir.
HH bond is what is broken here?
HH bonds, sir.
HH bond, 3 HH bonds are enough, na? Three HH bonds are enough na, to break. Why 6
Yes,
are
sir.
Yes.
required? That is
Yes,
for
sir, yes.
formation. That is for formation. See, try to understand. Reverse is different. See, you are not understanding. See, for example, benzene you want to break. Benzene you want to break. How many CH bonds you will break?
Sir, 6, sir.
6 CH bonds you break. But here only 3 is required. HH na? You are getting
Yes,
how
sir.
many? 6H you are getting na?
Yes, sir.
And then
Yes, sir. Got it, sir.
any other question? Okay, fine. Thanks for bearing. So get ready for the revision session. See you all.
Yes, sir.